1.6 talks about determining a quadratic equation given its roots. So if I gave you the roots and you had to give me an equation, the easiest form of the equation to put it into would be factored form. And that's because if I told you that your root was r, you'd just put it into the first bracket as the opposite of r. And then if I gave you s, you'd put it into the equation as the opposite of s. Number 1. Find the equation in factored form for a family of quadratic functions given that the roots are 4 and negative 2. So they've given you the roots, and we have to put it into factored form. Okay, so there's factored form, and I'm going to replace each of the letters with the roots that they told us. So they gave us 4, and I'm going to put the opposite. They give us negative 2, and I'm going to put the opposite. Now the thinking behind that is, if we went further with the equation to find the x-intercepts, we would get from this bracket x equals to positive 4, which was the first one. And then from this bracket we would get x equals negative 2, which is our second root. Okay, so that's just a little bit of a check. Now we don't know what a is, and since we don't know what a is, we're going to get a family of quadratic functions. What we mean by that is, if a was 1, you get a very normal looking parabola, versus say if a was 2, you would have maybe a stretched out parabola. So what we're going to do in B is we're going to sketch a family of 3 members, and we're going to change up the a value each time. So let me show you how to do that. If we have the equation, and I'm going to say a is 1. So I'm not going to write it because it's invisible, but let's draw it out now. So we have one root at 4, one root at negative 2, and I know that it's going to be opening up because a is 1. But that could mean that your diagram might look like this, it could look like this, it could look a whole bunch of different ways. And that's not very accurate. I mean, in order to be accurate, we really need to know where that tip is, where the vertex is. That's going to give us the 3 points, and once we connect them, we get our nice U. So our next step is, we're going to have to find the vertex. It's kind of easy because what you do is you just go, if your two roots are 4 and negative 2, you know that the U is going to be symmetrical, so most likely it's going to be along the 1 line. Now let's say that you didn't have a graph and you couldn't really see where the middle was. Well, I'm going to show you a way of doing it so that you can calculate the middle point. And that's if you take your roots 4 and negative 2, you add them together, and then you split them in half, which is just you taking the average of your 2 roots. That's going to give you the x value of your vertex. Okay, so we're going to just solve for this. 4 plus negative 2 is 2, divided by 2, and then x equals to 1, which is what we said. Okay, now the thing is, even though we know that it should be along this 1 line, we have no idea where exactly it's going to be. So we need to find out how far down the y value is going to be. And we do that by taking our x and subbing it back into our equation. Okay, so wherever you see an x, we're going to put a 1 instead. And we're going to solve for y. Okay, so your vertex is your x value, which was 1, and your y value, which is negative 9. So along the 1 line, that's where our vertex is, and now you can draw your u. Whoop, I'm a little bit off, but that's okay. Y equals x minus 4 and x plus 2. What we're going to do now is we're going to switch up the a value. So instead of 1, I chose 2 other ones, one in green and one in blue. In the green case, I did a equals to 2, and in the blue case, I did a equals to negative 1. Now what I want you to notice is that in either case, your roots have not changed. Okay, and because they haven't changed, your x value, which was the middle number between those 2 roots, should not have changed either. So your vertex should always start with the exact same number. The only number that's going to change is your y value. So once you sub in 1 into your new equation, whoops, that was moved over, but anyways, you're going to get a new y value. Okay, now that we have both vertexes for the green and blue, let's just graph those ones as well. The green one should have the exact same roots, and I believe it was 1 and negative 18. Whoops, that's a little bit too far, so next time I have to draw my graph a little bit bigger, but you get the idea. Okay, so it should be a little bit stretchier. And the blue, since A was negative 1, should be a flip. Okay, so you have your two roots, and then I believe the vertex was 1 and positive 9 this time. And that's exactly as we would have expected it to be. So that's how you draw a family of quadratic functions. Now another type of question is if they actually gave you the diagram and you have to go and find the equation. So what we're going to do is we're going to write out our kind of skeleton equation with nothing in it. Okay, completely blank. And we're going to take a look at the diagram and see if it gives us any information. So it does. It tells us our two roots, which means that r should be 0. You can put a plus 0 or a minus 0. It really doesn't matter because it's 0. Now the 6, you have to do the opposite. So that's going to be in there. Okay, and then you're going to get something like this. All right. We run across the exact same problem. We have no idea what A is, and we really need to know in this case. So what we're going to do is we're going to use this extra point that they gave us. Now the extra point in this case is a vertex, but it could have been anywhere along the parabola. It doesn't matter. What you do with it is you take the 3 and you use it as your x value, and you take the 9 and you use it as your y value, and you sub it into your x's and your y. So y is 9, and your x's were 3. Notice that all you're left with now is your a, so you can solve for a. Okay, let's move this up just a bit. 9 equals a, 3, and negative 3. A times 3 times negative 3 is a with a negative 9. Don't forget your brackets, or else it looks like a minus. And if you really don't want to write your brackets, put the 9 in front, and then divide by negative 9 to get rid of these, which is negative 1. That means that our overall equation is your a value, negative 1, not going to write the 1, x plus 0, not going to write the 0, and x minus 6. So that's your overall equation for this parabola.